The calendar now reads December. We're a third of the way through that month, actually. So it is now time to update my winter weather predictions for the current winter. I'm meteorologist Tan Leach bringing you this update. And the annual disclaimer side. This is a long-range forecast intended to provide general sense of what may happen in the coming months. It is not that this is for sure happening, nor is it an excuse not to be prepared for any extreme weather events or cold temperatures. Also, as a side disclaimer that I put in December only, I do not include any forecast models in this forecast. It solely relies on analog years. Essentially, it takes my October outlook, updates it using the same methodology to December. So that being said, what is my methodology for the few of you who may not have been here in October? I use an adjusted analog year approach using ENSO via the Oceanic Nino Index, confirming it using the Southern Oscillation Index. I use the Pacific Decadal Oscillation, the Quasi-Biannual Index, the current sunspot count slash percentage of the way through the solar cycle. As a side note, the analogs are not weighted equally. Analogs that are closer to this year's conditions have a higher weighting. Adjustments to analog years can be made using statistical analysis, which has been since 1940. If there is a statistically likely or unlikely chance of something occurring, analogs will be adjusted unless if there is a clear trend in the analog years showing the opposite. I will also take a look at general trends based on the previous season when appropriate. All forecasts will cover what has happened in one out of every 3 winters at the Portland airport. Adjustments to past data, snow before the 1970s have been adjusted to a 4.3-inch average per winter on analogs. Temperature departures have been adjusted to the averages at the time of which they occurred. And since my analogs go all the way back into the 1870s as the earliest analogs I am eligible to use due to where downtown Portland data started, analogs that are used before 1940, I've adjusted the precipitation totals to a PDX equivalent, which is 83.8% of what downtown gets. All right, now that that's out of the way, what does the data and other oscillations show? So starting with the ENSO outlook, and this the same 7 suite of models I used, not really that much has changed in terms of the overall average being right around 6/10 of a degree below average, suggesting weak La Nina conditions. However, this November, December, January timeframe, which we're almost halfway through, was the coldest 3-month average that I could find. So as a result, that does not make me confident we're going to be in a firm La Nina, and I think it's most likely going to be similar to last year, where it was a brief dip into La Nina conditions and then back to neutral. So officially, it would be ENSO neutral. I did notice there's less outliers this time, with the only outliers being the Euro model, with it supposedly starting to warm up in the ENSO territory, and then the Mateo France forecast, which is in the moderate La Nina territory. I will note that the Euro model has not updated it in a while, so that is skewing the average a little bit down. So for major windstorms and ENSO, you want to be near or zero, so perfectly neutral. That is the highest chance of seeing a major windstorm. And then Pacific Northwest, the most active time period, really, you need anywhere between about a weak El Nino and a weak La Nina. So we are in between that. So that does increase the risk at least slightly for a windstorm, depending on what happens with the analogs. In terms of what happens otherwise during these ENSO states, neutral year, which is my favorite for this year, median snowfall is 2.6 inches. The average temperature departure is 6/100ths of a degree below average, with the median lowest temperature at 19 degrees. The water year rainfall median is a little bit below average at 32.5 inches at PDX. The Eugene equivalent would be about 37 inches, and with about typical mountain snowfall. With weak La Ninas, it is the snowiest ENSO state with a median of 7.3 inches. The average temperature is 64/100ths of a degree below normal, with the median lowest temperature being 17 degrees. The water-year rainfall is a little bit above average, about an inch and a half above average. However, I have noticed that weak La Nina years are very chaotic when it comes to the water years, because the driest water year was a weak La Nina, and two of the top four wettest years were also weak La Nina. So you could get both extremes still with a weak La Nina. On average, mountain snowfall is right around 115% of normal. So the Southern Oscillation Index the last 2.5 years, when I last talked to you all in October, the Southern Oscillation Index was right here. Positive, but not showing Nina-like conditions. Positive SOI signifies La Nina-like conditions. It was showing positive for a little while through the latter half of October and into November. However, it has since crashed in the last week, and we're now back down for a 30-day running average to just a little bit positive. Gives me a little bit more confidence that we'll be in that more neutral-esque versus in the Nina-esque side of things. Pacific Decadal Oscillation still firmly negative, though it has climbed. That being said, when your July output was the lowest on record, climbing to a minus 1.6. Yeah, seems like a lot, but that's still firmly negative. I touched on this in October, the sea surface temperatures. At the time, it was looking like the central North Pacific and may have had a return of the blob, but that has since cooled off. There is still a patch of warmer than normal temperatures in that 1 to 2.5 degrees Celsius below normal, but closer to our coast that has tapered off significantly, and there are cool eddies that are also forming out there. And then the QBO values, we are still firmly in the easterly phase, but I do notice that there is a sliver of westerly winds right in that 10 to about 13 millibar levels, signifying that the flip to westerly is just beginning. That's not going to be in time for this winter, however. This is a easterly phase winter. Sunspot count a little bit past solar maximum. Nothing's really changed. I didn't bother to update this from the October forecast. So, how does this affect my analog years? I trimmed down the amount of analog years I've had from 27 to 15, though I kept 5 top analog years. I changed one of my top analog years where my old top analog 1893 to 94 has been swapped out for 1898 to 99. The other 4 top analog years do remain 1921 to 22, 1967 to 68, 2013 to 14, and 2017 to 2018, though the weighting of each analog has changed. In October 2013-14 was my top overall analog year. Now it is 1967 to 68. Taking a look at the comparisons, starting with the oldest two, 1988 to 99, the more I looked at it, the more I felt that ENSO probably is the best match overall. It was a super cold neutral, briefly dipping into La Nina, then back into neutral, same as the winter before. However, the thing going against it is that the PDO was mixed. It did end up dipping into the negative phase later on, though it went back positive late that summer. Sunspot progression was near the solar minimum, however. 1921 to 22 was a super cold neutral and was a negative PDO with a blip, and the solar progression was also near the solar minimum. 1967 to 68, it was a super cold neutral with a blip into weak La Nina, very similar to what we're having this year. And 1966 to 67 was a top analog last winter as well. PDO was negative with a blip as well. QBO was firmly in the easterly phase. Solar cycle near the solar maximum. 2013-14, one of the reasons why I changed the weighting of my analogs was because I made a mistake in the October forecast, and I did not realize how firm it was in the westerly phase. I accidentally looked at the wrong time frame. So because of that, Now, looking back, I don't think it would have affected my top analogs because it's still in the top analogs here, but I do want to point that out. PDO wasn't deteriorating negative. It has the best match in terms of the sea surface temperature for a cold neutral to La Nina year, which is the biggest reasons why it's included. The its weighting decreased from 35% all the way down to 15 for Portland, 20% for Eugene. 2017 to 18 was a weak, moderate, borderline La Nina. This is the only one that I can firmly say was a true La Nina. PDO was turning negative, and the QBO was easterly, though the solar cycle was closer towards the minimum. Take a look at the extreme events, and we'll start with the top two oldest years. 1898 to 99, there was a mid-December light freezing rain episode. By the time this is posted, it would have been about 3 days out from now. Newsflash, we're not having freezing rain the next 7 days. Marginal snow setup to close out December between Christmas and New Year's. A lot of snow, but based on temperature warming, probably wouldn't happen today. Arctic blast did happen in early January after a little interruption with 4 sub-freezing highs and 11.6 inches of snow at PDX. Early February, there was a major Arctic blast with the lowest high and low temperatures being 21 degrees and 9 degrees, both occurring on the 4th. However, it was a primarily dry Arctic blast as the only snow was on the transition day out, 5.5 inches. Both Portland and Eugene did get in on that action, though I do not have temperature data for Eugene in, on this analog year. I also did not see any ice, which that's been relatively unusual for a lot of transition events because a lot of times that cold air can stick around in Portland and cause freezing rain instead of snow. 1921 to 22, the November ice storm of the century, December Arctic blast with some light snow, and another mid January cold snap with another set of sub freezing highs, though also light snow, and then late February dry and breezy cold snap. The other top five analog years, the more recent ones, 1967 to 68, a mid-December cold snap with about 4.8 inches of snow at PDX. That occurred right around the 20th of December. No sub-freezing highs, however, and this was PDX focused. Late January cold snap with 2 to 12 inches, depending on where you were at in the valley, and a sub-freezing high. For the warm weather lovers out there, it did hit 70 degrees in late February. This is the only analog year that did not show any sort of winter activity. And bad news for any skiers or riders, 60% of the average peak snow depth. And that occurred in May. It did not occur in the typical peak snow depth of April 1st. 2013-14, there was a major Arctic blast in the month of December and February. December, there was a South Valley snowstorm leading to negative 10 degrees in Eugene, while the snow was more widespread in February, with freezing rain being involved in that, and absolutely nothing in between. Slow cascade snow start as well. 2017 to 18, we had a white Christmas that year. See if that happens this year. That's about 2 weeks out from the time of this video. Second cold snap in February with more widespread snow as well, with absolutely nothing in between. Slow cascade snow start as well. So these are the only three top analog years that I have that have good snow data. Not looking the best for skiers or riders out there, and there's hardly any snow up in the mountains right now. So the delayed snow prediction from October based on these three analog years has come true so far. Taking a look at the data from the analog years, the water year rainfall, starting with PDX, the overall median was 31 inches. Top analog median was 31 inches as well. And then the weighted analog median was about 33.6 inches. So it has creeped up a little bit. The biggest cluster that I noticed was between about 30 and 33 inches, with everything else being a little bit more scattered about. Water year rainfall in Eugene, overall, it was a little bit more scattered at Eugene compared to Portland. The all analog median was 39.23 inches compared to an overall average of about of 40 inches and change. The top analog median is lower at 33.65 inches, and the weighted analog median of a titch below 37 inches. Temperature departures from average, this is trend adjusted at PDX or downtown Portland before 1940. All analog median was 0.8 of a degree below normal, top analog median 1.8 degrees below normal, and the weighted analog median about 0.6 of a degree below normal. However, one thing I did notice is that a lot more years that I deleted from the analog list had below normal temperatures compared to above normal. Before it was about 20% of analog years had above normal, and the vast majority of them, except for the three I have listed here, were within half a degree of normal. Now there's 6 above normal out of 15, so that's 40% chance if we're just taking the raw data here. And two of my top analog gears are also a little bit above normal. That makes me even less confident than I was in October about the temperature forecast. And there's going to be some adjustments to that specific forecast. In Eugene, still leaning a little bit below normal on that overall median, about 0.4 of a degree below normal. Top analog median further down at 1.5 degrees, and the weighted analog median of 35 hundredths of a degree below normal. Lowest winter temperature, trend adjusted at PDX. The median was 16 degrees, top analog median of 14, and the weighted analog median is 15. I did notice the recent analog cluster really was clustered either at 23 or 24 degrees, while the longer range analogs were clustered right around 15 degrees. So I had to make a decision of which tier I wanted to put it in. So in my final forecast, I ended up leaning towards the modern analogs in this case overall. In Eugene overall saw a little bit warmer temperature-wise compared to PDX. The overall median was 18 degrees. Top analog median was 19, and the weighted analog median was 15, though this is still skewed down by 2013 to 14, despite me reducing the weights significantly. For the adjusted snowfall, there is now no analog year above 10 inches. However, there is also no analog year that was snowless either. The only one that was under 2 inches was 2000 to 2001, and that is not a top analog year, though I will say it was one of the better matches for the solar cycle. The overall median was 5.3 inches, the top analog median 7.3 inches, and the weighted analog formula came out to be about 6.5 inches. So that has creeped up a little bit. The adjusted snowfall in Eugene, this has gone the opposite direction and creeped down slightly. The overall median was about 5.5 inches, top analog median about 3.3 inches, and the overall weighted formula came out to be 5 inches, again skewed higher from the 2013 to 14 year, which was one of 2 years above 10 inches, the other being 2021 to 2022. Otherwise, the biggest cluster for both Portland and Eugene came in this 2 to 4 inch bracket. I will rewind to Portland to show you that. And then in both, there was also a second cluster in the 6 to 8 inch range. So moving on to our historically significant trends and statistics. There's been 10 consecutive winters that have had measurable snowfall. This is a record high. Chance of an 11th occurring was 2.7%. However, analog years do disagree with this, so I am leaning with the analogs as a result, especially once we get into February. Only 3 winters have produced a temperature under 20 degrees with less than an inch and a half of snow, all 3 of which had 0 snowfall. There's also been 5 winters in a row where the total days with snow on the ground have been above the median. This is a record high, though I will state that this statistic is a little bit under question because of the way medians work. If we get another that is above that, that would change the median to 2 days, which is what we saw last winter. So, chance of a six occurring in general, ignoring that, would be 1.5%. Then there's also been no deep Arctic blast, which I define as 12 degrees Celsius below zero at the 850 millibar pressure level above Salem for 11 winters. That's where they launch all the weather balloons from. Chance of a 12th occurring is 4.7%. And continuing on here, for our ENSO neutral analogs, all the snowless winters that have had ENSO neutral have been with the westerly QBO at the 20 millibar level on January 1st. We are firmly in the easterly phase, however, I don't see that changing in the next 3 weeks, despite that westerly phase starting to appear in that 10 to 13 millibar level. It's just 3 weeks is not long enough for it to flip at 10 millibars, usually, though there have been exceptions. Statistics only date back to 1955 to 56 in this case, because this is when QBO data became reliable. Also, 13 out of 14 years with 18 inches of rain by the end of December had 40 inches or more for the water year. As of today, this was at 13.15 inches, and I don't see that hitting 18 inches as we would need 5 inches for the rest of December. That does not seem that likely. Um, for anyone who wants a 40-inch or more water year, you don't need 18 inches. I've noticed that 16 inches is the cutoff for that. We could hit that by the end of December, or the average rainfall between now and the end of December is about 3 inches anyway, so that is definitely possible that we could hit that and break that threshold for possibly 40 inches or more, though analogs do disagree with this statistic as well. And going on to the same one I used in October, but didn't actually use in the forecast because of the questionable status of last year's ENSO, is that second year Ninas almost always have a drier winter season than the previous season. Because I am predicting this winter to be truly ENSO neutral compared to a weak La Nina, and the fact that last year was also officially an ENSO neutral, just briefly dipping into La Nina, that brings this into question. Though for reference, last winter was 14.06 inches. I did not factor this into my final prediction overall, which, let's get started with said final predictions. Start with the basics. Only slight changes for the water year, near to slightly below normal. PDX 31 to 39 inches with a 34-inch best estimate compared to a 37-inch average. South Valley 33 to 42 inches with a best estimate of 37 inches compared to a 40-inch average. Temperature departure from normal, near average within about a degree of average, though this is still low confidence, a little bit more confident than I was in October. Windstorms, I'm downgrading it to a typical strength, 45 to 55 miles per hour. It's entirely possible that our strongest wind gust this year comes from an east wind event rather than the traditional windstorm. Lowest running time temperature, my confidence on this has gone down compared to October, 16 to 24 degrees. The first time I'm using this middle tier. Best estimate is about 17 degrees. Most likely to be active, double peak is definitely possible. December and February came out the strongest. At least one of these will be less than a week on the cold and the snow side. February did come out stronger than December on my analogs. Moving on to the rest of this, and we'll start with the mountain snowfall. And there has been some big changes with this. Mountain snow depth on April 1st, this is tilting below normal significantly, 45 to 90% of normal for the snow depth on April 1st. This is not good news if you are a skier or a boarder. This is historically bad season so far. And the analogs, yeah, do show them getting better, but it's not showing that we'll be getting to average anymore, especially on the top analogs. However, because of the delayed start, I have decided to give myself a guaranteed half hit for that because that part has come true. Then for the valley snowfall, I have not changed the overall snow forecast. I am still saying 2 to 8 inches. PDX, I am putting your best estimate in that upper or cluster at 6 inches. In the South Valley, I am putting your best estimate at 3 inches. So I have decreased it a little bit. Chance of a no snow winter is at about 10%. So I have decreased that a little bit. So that is it for this forecast. Thank you all for watching, and until either the next PNW Weather 101 episode, or if we get something later this December, that video, please stay safe out there and take care.